Hi, myself Dr. C. Prakash, Assistant Professor, Department of Mechanical Engineering from Rover Engineering College, Perambalur. I am going to take a class on heat treatment process.
First, we see the introduction about the heat treatment process. First, what is heat treatment? It is a process of heating the metal, and then we put particular time to heat the metal, and then we cool. So this is the three-step process. First, we heat the material above the recrystallization temperature, and then we put particular time after we are cooling the metal. It is the controlled heating and cooling of the metals for purpose of altering their properties. What properties we expect depends upon the heat treatment and then cooling process, and then particular time we can make the material depends our own way. Purpose of heat treatment. During this heat treatment process, we can achieve the following improved properties. We can do the heat treatment by different methods. By using that heat treatment, we can relieve the internal stresses of the material, to improve the machinability process, to change the grain size, to soften the metal. We can improve the hardness of the metal surface, and metal also we can whole material we can change the hardness and improve the mechanical properties, magnetic properties, electrical properties, thermal properties, and also we can increase the wear resistance of the material and corrosion resistance of the material. Stages of heat treatment process. It is a three-stage process. First, we heat the metal above the critical temperature, and then holding at the particular time to allow the necessary change, and then cooling the material. First step, what is critical temperature? In this critical temperature means at what temperature the metal change their transformation, that is called critical temperature. In this temperature, the phase transformation occurs of this material. Their crystal structure is changed from one form to another form. If suppose we take the steel, means around to 723 degrees Celsius, it is this critical temperature starts. We can say it is a lower critical temperature. At this temperature, the transformation of changes from their structure of material changes to perlite to austenite. In this same upper critical temperature, around 800 degrees Celsius, at this temperature, the structure of perlite is fully changed to austenite. It may be changed to 800 degrees Celsius to somewhat 900 degrees Celsius around go, but it changes from metal to metal. If suppose we take for aluminum alloys, this is critical temperature starts from 400 degrees Celsius to 500 degrees Celsius. If suppose we take the titanium alloys, like the hardness material, titanium alloys critical temperature is around 700 degrees Celsius to 1000 degrees Celsius. In this temperature, their transformation changes. So according to the metal's critical temperature, we can fix the heat the material. So identification of critical temperature also the one of the main factor for this heat treatment process. Then we can show the time. Depends upon the time, their mechanical properties will be changed. If suppose we want to soften the material, we can use particular time. If we want to harden the material, depends upon the hardness and the carbon content, we can change the material. If you are a researcher, you can change these three properties. You do your perfect research. If suppose you are making a new material, if you want to improve their properties, you can choose the first you check the critical temperature of this metal, and then you can do some trial works. You can after that do your research. You can identify at what temperature, what kind of cooling method it will be improved on that our expected properties. If we take the cooling, for this cooling method we can use different types of cooling. We can furnace cooling itself we can do. Room temperature we can cool the material, or sometimes using any of the liquids. This means quenching liquids. The liquids may change, different material liquids are used, ordinary water used, some oils, we can use, depends upon the liquid use. Quenching medium, we can say quenching medium, depends upon the quenching, their properties will be changed. We can see what are the quenching method, how times will affect their properties in later part. I already told heat treatment is depends upon these three properties: method and rate of heating and cooling, and what kind of furnace is used, what kind of quenching medium used. These parameters only decide the material properties. Now we see the types of heat treatment process. Generally we can decide the two types of heat treatment. One is bulk heat treatment, another one is surface or case hardening heat treatment. In further, bulk heat treatment is divided into following three types. Following, we can show the five types. We can show, first one is annealing, normalizing, hardening and tempering. Tempering is again divided into Mott tempering and Haas tempering. I say particularly any of the important things about this process, and then later we will see depth. Annealing is softening process. Annealing is a softening process. So we for softening the material, we take much more time for heating, and then we cool slowly, so we can reduce the material's softness. If material softness increases, means their ductile property will improve. So annealing is used for this purposes. For normalizing, annealing are both of them nearly same, but small changes only for doing in normalizing process. In normalizing, annealing generally cooled in normalizing is little differ from annealing, because normalizing material are more strengthened than annealing material, because annealing process are done only in furnace cooling itself, but normalizing doing in a still cooling air or at room temperature, normalizing process can done. This is the main difference between annealing and normalizing. And after hardening, hardening is the only purpose of making the material more hardness. During this process, material is more hardened and brittle. For hardening the material, we are using any of the quenching medium to harden the material. Quenching medium may depends upon the carbon content and the material properties. Different quenching mediums are we can use it. There is the tempering process are there. This process only doing for the hardened steels. These hardened steels are already told brittle and more hardness. For this more hardness materials may difficult to messing, and it is more brittle means we can it is easily fractured. So improving the fatigue strength, tempering process are used. In this tempering process, again reheat the material and then slowly cooled at the room temperature. Another these are two different purposes, depends upon the Mott tempering temperature and Haas tempering temperatures these processes are doing. Remaining are surface or gas hardening. In this process are bulk hardening process. Bulk hardening means the whole material is fully changed their properties. But in surface or case hardening, only the particular surface only their structure or their properties will be changed. It can be done for the two methods. One is thermal methods, another one is thermochemical methods. In thermal method, we using different heat is applied on that surface, and then we cooled, because it is a immediate cooling, then only it can surfaces only harden. Otherwise it may, if suppose we heating the surface, immediately we are cool the material means only that temperature is transformed on this that surface only. So heat the surface only can harden. If you take the another these are four types of thermal oriented heat treatment process are there. One is flame hardening, induction hardening, laser beam hardening, and electron beam hardening. We can see later in detail. Another one is thermochemical methods. In this method some process they are using some chemicals are applied on that surface. You can increase the hardness. If suppose we are taken into carbon content, if we increase the carbon content on that surface, the surface hardness will be increased. Naturally carbon having the more hardness than the some metals. For that metals we applying carbon atoms to that surface, it will mingle with that surface, it will improve the hardness. For carburizing carbon atoms, nitrogen are applied on that. Another one is carbonating and cyaniding. This process we will see depth in later. If we see the annealing process, the same 3-step process. One is heating, another one is holding for particular temperature, and then we cool. Heating the material at the above critical temperature, and then holding for particular time, and then we slowly cool the material. For doing this annealing process, we can relieve the internal stresses. These stresses formed for solidification, machining, forging, this kind of process stresses can form. We can relieve the stresses, improve our, if it is a softened process, so ductility and toughness will improve. So to all softened materials, machining process also easy. It can eliminate some chemical non-uniformity. It can change the grain size, reduce the gaseous contents in steels. And these having different types of annealing process there. First one is full annealing. In this process we can obtain high ductility. Microstructure is coarse pearlite microstructure is endowed with such properties. These range temperatures are A1, we can see in this diagram, A1, A3 and A centimeter. The steel is heated above the A3 temperature. That means depends upon the carbon percentage it is changed. For this process we obtain the coarse pearlite structure. For this, for hypoelectric steels we did not heat above the A3 temperature. The same for hyperductile steels, we did not heat the above A centimeter for avoiding the continuous network of productile cementite. It is for cooling only furnace. Another one is process annealing. In this process, material is heated below lower critical temperature and held for sufficient time and then cooled. Cooling rate is more important for this process. Next one is stress relieving annealing. The name itself we can identify, it is used to remove the stresses formed due to welding, machining, grinding. These process makes this stresses. For avoiding these stresses, we are using this process. Next one is recrystallization annealing. In this process, heating the metal above its recrystallization temperature. For that only new stresses are formed, or this time there is stress-free grains are formed during that time. For this process, ductility property is improved and hardness and strength also slightly reduced, and so machining for this metal is improved. Heating the metal above the recrystallization temperature is more important for this process, and then cooling the metal slowly. Next one is spheroidizing annealing. In this process, transformation of microstructure of steel changes the structure of cementite into spherical structure. That's what they are saying, spheroidizing. In this process, metal steel is heated lower the air critical temperature, that means lower the A1 line, and held for a particular period and then cooled slowly. That's what that time is allowed for cementite is transformed into a spherical form. For doing this process, material ductility is improved. At the same time, their property is hardness is reduced, so that reduced hardness makes the material machining property easier. Thank you. In this video we are till now seeing the heat treatment process introduction and their annealing process and its types. We will see the next video by remaining heat treatment process.